Lower limb prosthetics is the project that I specifically worked on at Vanderbilt. My project was a transfemoral prosthesis, so that is one that has a knee and an ankle. They also have one that is just an ankle, transtibial prosthesis. Lower limb prosthetics are useful when amputees lose their legs. So there are more than 2 million amputees just in the United States. This guy is Craig. He was one of the testers that I worked with, and he got his leg bit off by a shark. Some other people lost their legs due to cancer or other types of trauma. For above knee amputations, trauma or disease is the main kind. So cancer, or they had an accident. For below the knee amputations, then when they just get their foot cut off, the main cause of that is diabetes. People with diabetes get peripheral neuropathy, so they lose the feeling in their legs or their feet. They can't tell when they get cuts or something. So if they get a cut, then they don't get it taken care of. It turns into gangrene. They end up losing their toe, then their foot, then their ankle. So eat healthy, don't get diabetes. Only about 20% of amputees are transfemoral. So out of 5 amputees, 1 is transfemoral and 4 are transtibial. So 4 of them will just be missing their foot and ankle, and 1 will be missing their whole leg. Now, although conventional prosthetics are pretty decent for allowing amputees to walk around, one thing they can't do is climb stairs. A passive prosthesis, which is their normal kind, it has a resistive hinge at the knee. And now the ankle is a carbon fiber spring. So they get a little spring out of that and it's stiff. But the knee is not. It's just got resistance. So if they bend it too much, it's not going to support them. And if they're trying to climb stairs, the knee will just collapse. So the kinds of problems that amputees experience based on their pathological gait can be like extra wear and tear on their hip. They have a really unsymmetrical walking. So you can tell when someone's an amputee because they'll kind of like hike their hip up a little bit to prevent the prosthesis from scuffing the floor. The prosthesis is usually a little shorter than their actual leg so that it won't hit the floor too much, but you can tell when they're swinging it. Also, it's lighter, so the knee joint will bend faster than their normal leg sometimes, and even when they're wearing pants, you can tell. When I was desperate for finding test subjects, I used to just start volunteering at random events around Nashville, hoping to meet amputees. And when I saw one, I'd run up to him and ask him about his leg. And they were usually a little bit taken aback, but most of the time they were only missing their foot and not their knee also. Anyway, so there are a few dangerous side effects, besides the fact that it looks a little weird, which, I mean, if you like the bionic look, some amputees actually like it, and they can even get a cosmesis that fits over it, so it has a shell that's the size of a normal leg, and then they can put different designs on that. So like some people have a t-shirt that they really like, and so their leg will, they get the t-shirt imprinted into the leg. So there are actually some really cool ways to do it, but the medical side effects can lead to problems later on in life. The way that amputees normally climb stairs is using a step 2 gait. So they step up with their good leg and bring the prosthesis up to meet it. Every stair pretty much is climbed using their good leg, and the prosthesis just kind of like gets dragged along. So that's extra work for their good leg, twice as much work. The solution here is to use a robotic leg. This one is the one that Vanderbilt developed. It's got a powered knee and ankle. There are belt chain transmissions. So it's 3 stages. And then the knee motor's here, and then the knee joint is up here. Then same thing with the ankle, the motor's here. 3-stage transmission puts the joint out right here. Then it's got a carbon fiber spring foot, and it has this adjustable pylon. So if somebody is short, we put a short pylon. If somebody's tall, we put a tall one, and then this can be at the right height for their socket. So this part right here screws onto a socket, and then the socket fits over the residual limb. This leg has position, velocity, and force sensors, in addition to an inertial measurement unit. So the motors have encoders. We can use that for position and velocity. Then in here is a load cell. So that measures how much weight is on the prosthesis, and that way we know if they're standing or sitting. And then there's an IMU with an accelerometer and gyroscope on the circuit board here, so we can tell if the leg is in front of them or behind them. And we use all of those signals to figure out, is their gait biomechanically appropriate and what activity are they trying to do?